We did a quick search of article counts for personal air monitor. We can see that there's an increasing attention on it. It seems double each year. Nowadays, people care more about air quality and how they affect human health. It is likely that more and more air monitor sensors will exist in the market. In order to formulate a better air monitoring sensor for asthma sufferers, it is important to understand what air pollutants are harmful for them. We found that there are 4 main air pollutants that trigger asthma, which are particulate matters, ground-level ozone, sulfur dioxide, and nitrogen oxide. We have 2 main challenges of air monitoring sensor. One is accuracy and data quality. It is a key issue since data of poor or unknown quality is less useful than no data since it can lead to wrong decision. EPA indicates that many commercially available sensors have not been challenged rigorously under ambient conditions, including both typical concentration and environmental factors. Furthermore, even if sensors are well characterized, performance criteria have not been developed in the US, regardless of the anticipated sensor use outside of the FEM criteria. However, using FEM criteria, which require data of high quality for purpose of monitoring compliance with the NAAQS, will likely to be too restrictive for many sensor applications. The table shows the requirement for air monitoring sensor in different application areas. From the bottom row, we can see that for personal monitoring, it requires precision and bias error that is less than 30%. Another challenge is lack of PM detection. Commercially available sensors are lacking for PM and hazardous air pollutants. Specifically, there are no commercially available direct reading PMS sensors, though they are under development and surrogates for PMS exist based on light scattering. Additionally, a complete lack of commercially available chemical substation PM sensors, with the exception of a handheld devices that measure light absorption on sample collected on a filter, which is relatively surrogate for black carbon. Currently, there are a few air monitoring technologies that can detect particulate matters. One of them is called acoustic energy monitoring. It has good sensitivity with a range of approximately 0 to 0.05 grams per standard cubic feet. The disadvantage of that is not sensitive to particles smaller than 10 micrometers. Also, since the probe distorts the flow, changes in flow velocity and particle size distribution will change the instrument response. Also, this monitoring does not measure mass and must be calibrated against the EPA's FRM. These devices are commercially available for approximately $12,000. Another technology is called opacity monitor, which have a typical range of applicability of 0.02 to 4 grams per standard cubic feet. The advantage of that is the monitors are an established technology and operate reliably. The disadvantage is that it is the least sensitive of the various optical approaches to monitoring PM, and is difficult to install. Also, it works well only under ideal operating conditions. These monitors have ranged in price from approximately $10,000 to $50,000. Light scattering technology can detect particles ranging in size from 0.1 to 15 micrometers and have a PM detection limit of 2 times 10 to the power minus 6 grams per standard cubic feet. The good thing is that it has excellent sensitivity, and this technology has a range in price from approximately $10,000 to approximately $30,000. This is the structure of light scattering. Once particles are pulled in by a fan, they pass in front of a laser. The laser reflects on a photo sensor. This allows the devices to instantly work out the size and the number of particles in the air. Here is some examples of air monitoring sensor in the current market. Air Quality Act is small Wi-Fi connecting monitor that is used to detect air pollution near homes. It can detect NO2, CO, and generate an air quality sensor network that is participated by users distributed across the world. Users can visualize data from the network map to change their action correspondingly. AirBeam is a wearable air monitor that uses light scattering technology to detect PM. It connects to an open source mobile phone app called Aircasting, and users can graph, map, and crowdsource their air quality exposures. The football is used to detect indoor air pollution, with a package of sensors to detect PM 2.5, CO2, CO, TVOC, temperature, and humidity. By connecting sensor with mobile phone, real data, alert, and advice can be sent. The device is aimed to prevent people from health issues caused by invisible air pollution by little adjustment. Spark is a low-cost, portable indoor air quality monitor. It is developed by researchers at Carnegie Mellon University. By using optical method, PM with its count and weight can be detected. It provides history and trend of data shown on the screen to see how daily life action can change the air quality readings. Also, it has data storage capacity up to 2 years, and those data can be downloaded from individual accounts. We can see that currently there's no single sensor available in the market that can detect both PM and gas phase species at the same time, and most of the air monitors are designed for all groups of people. So our aim is to pack chemi resistor with light scattering that is small enough to put into the wearable devices to better suit asthma sufferers' needs.